The tag for this video is FE state hooks. With our user registration form, the user needs to supply a username and a password. We need to store those in memory so we can check them for validity and so we can submit them with our request. We'll start by storing the username. We're going to use a hook. The hooks all begin with use underscore and then they have some word. So we're going to use state. We put in the scope, which is CX, and we'll make a new string. And we'll do the same thing for the password. The way that hooks work with our use state, we are creating some state and we're saving it into CX. So that's going to get saved into the scope. This scope is managed by Dioxys. So whenever we call the register function, Dioxys is going to grab this scope here and update the state that we've provided. This is especially important with Rust because whenever a function call ends, everything within the function gets deleted, which would delete any state that we have. However, since we have this scope, we're able to maintain state across multiple function calls. Right now we have two sets of state, and that's okay, but we can do better by organizing it into a single structure. So we're going to do that now. We're going to create a new structure called page state. And this structure will contain all of the state for the entire page. So we have a username, and we have a password. Now the useState function returns a hook. So we have a hook right here. And if we mouse over, we'll see the data type, which is useState. So we're going to use that as our data type in the page state. So we'll hop up here. We'll change the data type. This will be useState. So the thing with these useState hooks and all the other hooks in Dioxys is we need to call them in the exact same order every time we call our register function. So whenever you're dealing with hooks, we need to put all the hooks right here at the beginning in the same order. You can't use any loops and you can't put them in conditionals. Let's modify this a little bit. That way we have all of our hooks inside the page state. I'm going to make a new impl block. We'll make a new function. And then for these, we'll just copy and paste. We'll change that to colons. All right, so now we just moved our state into the page state. These need to be cloned. These useState functions return borrows from the scope. So if we mouse over this real quick and take a look at the signature, we'll see that it returns a borrow. These are pointers, so if we just call .clone at the end, we can get rid of the borrow and keep our own version of the hook within our page state, which is what we're doing here. We're cloning it, and then we're keeping that copy here in the page state structure. The great thing with hooks is whenever we access the username, since it's a hook with the useState hook, whenever we access it and change it, anything else that accesses this username hook is going to be updated automatically. So we can actually pass around copies of this useState anywhere else into our application, and whenever it gets updated, everything using it will get updated as well. Now let's create our new state within our register function. And so now we've created our state. So now what's happening is we create our new page state, which is just a regular page state structure, and we wrap it in the useRef hook. And the useRef will allow us to pass references of the page state around to various components within our application. So just like useState up here, useRef works very similarly. useState only has owned values, so it can only be strings or some number. useRef, on the other hand, works with borrowed values. So we're going to borrow the entire page state structure with the useRef. And since we're borrowing it, we'll be able to easily share the entire page state with all the various components on the page. Now that we have the state for our page, we can start creating the input boxes where users can input their username and password, which we'll be doing in the next video.